apply the laws of exponents to evaluate expressions that include integer exponents. Think about this question during the lesson. Marcella is playing a card game with some classmates. 4 matches have been made. It is Marcella's turn, and she chooses 3 to the power of -1. She needs to know which card would complete her match. In 3 to the power of -1, which is the base?
Select your answer.
Begin by organizing the information in a table. We'll start with the largest number. 3 cubed is equal to 27, and work down. Now you can look for a pattern. What relationship do you notice in the evaluated form column? The pattern is that each number is the previous number divided by 3, or each number is 1/3 the previous number. As the exponent decreases by 1, the product is divided by 3. We can use the pattern to find 3 to the power of -1. 1 divided by 3 equals 1/3, so 3 to the power of -1 is equal to 1/3. The card Marcella needs is 1/3. You could also apply the laws of exponents to solve the problem. Apply the quotient of powers law. When dividing 2 exponential expressions with the same base, subtract the exponents. 3 to the power of 0 minus 1 is equal to 3 to the power of -1. You can also write the quotient as a fraction. Evaluating each exponential expression shows that the fraction is equivalent to 1/3. The negative exponent law states that a to the power of -1 equals 1 divided by a, and the quantity a divided by b to the power of -1 equals b divided by a, assuming a and b are non-zero real numbers. And we get the same answer. Marcella needs to find the 1/3 card. Nice job, Marcella.
Evaluate.
So 1/2 to the power of -1 will be 2/1, and that would equal to 2. Then we have b, 5/9 to -1, and then that would be 9/5. Oh. And then we have c, -7/8, -1. And that would be 8/7, -8/7. That's it.
Evaluate 4 to the power of -2. To begin, write the exponent -2 as a product of 2 numbers, 2 and -1. Now, apply the power of a power law to rewrite the expression. A to the power of m times n is equivalent to the quantity a to the power of m to the power of n. So, 4 to the power of -2 is equal to the quantity 4 squared to the power of -1. Now, apply the negative exponent law. The quantity 4 squared to the power of -1 is equal to 1 divided by 4 squared. 4 squared is equal to 16. So, 4 to the power of -2 is equal to 1/16. In general, assuming a is not 0, a to the power of -n is equal to 1 divided by the quantity a to the power of n. Evaluate.
Okay, A is 10 over 13, negative 2. So this would be 10. Oh, let me get my pen marker. Okay, so this would be 10 to 10, 13, negative 2, negative 2. And then you need to evaluate. So 10. Okay, and that would be 100 over 169 over 100, because when it's a negative 2, negative is the reciprocal, right? So we solve it and then it's the reciprocal. So 169 over 100. Then B is negative 2 times negative 5. So that would be 1 over 2. Negative 5 is the exponent, and then that will equal 2 times 2 times 2 times 2 times 2 times 2. That would be 1 over 32. And it's a negative because of the exponent, and it's an odd exponent. So the last time we multiplied 2 would be negative. Then we have negative 3 halves with the negative 4. So then we have 2/3, negative 2/3, and then they're both negative 4. So this will be 2, 16, 3 times 3 times 3 times 3 times 3, 81. And then because it's even and negative, it will eventually become positive. Negative times negative is positive. And so we have now evaluated all three.
What is the approximate area covered by the onion cell?
The onion cell is generally rectangular, so multiply its length and width to find the approximate area it covers. Apply the power of product law. So we take the length and width, length times the width, and then they both have the same exponent. So you multiply them with the exponent of negative 2, and then you evaluate the power, and then you get the answer of approximately this number. Okay, so let's evaluate these here. So, okay, so we have 2/5. It's going to be 5 over 2, negative 4. And then this would be 4 over 5, negative 4. And so then you would multiply them together, and you would get 20 over 10, negative 4. And then Um, some other we should simplify. So now, let's see. I think we should simplify it. I think that'll make it simpler. So then if we divide by the greatest common factor, that would be 10. So 20 divided by 10 is 2. 10 divided by 10 is 10. So this will be 2 to the power of negative 4. Let's just do equal. Okay. And so then now 2 to the power of negative 4 would be 16. And it'll be positive because it's a negative, it's even exponent, so it's going to come back out to be positive. All right, so I'm going to erase this and do the next one. All right, so the next one is B, 2 and 5/10 to the power of negative 3 times 0 and 2/10 times negative 3. So then we multiply 2 and 5/10 and 2 and 5/10 times the 2/10. That's going to equal 0.5 to the power of negative 3. And then 0.5 to the third power is 125, 0.125. And that's that for B. And that would be negative because it's an odd exponent. Now let's move on to the next one. All right, we have negative 6 to the power of 2 times 2/3 to the power of negative 2. So we can do negative 6 times 2/3. Let's see, in my calculator. Okay, so that'll be 4 to the power of negative 2. And then that would equal 16. I skipped a step. I forgot that with a negative, we do the reciprocal. So this would actually equal 1/16 as the answer. And now that I have corrected myself on that one, I believe I need to go back and correct myself on B because of the negative exponent. Because it was decimals, I forgot that I still needed to have that reciprocal. So I'm going to rewrite B, and I have I'm going to write as fractions just so you can see the reciprocation. So 2 and 5/10 times 2/10. That's what those decimals are as fractions. And then this is going to be to the power of negative 3. I'm just going to erase this to give more space. And so now, I have the reciprocal. So first, this is a mixed number, so I'm going to make it an improper fraction. So it's going to be 25/10 times 2/10. So now the reciprocal of that would be 10 over 25 times 10 over 2. And then we can multiply straight across. I'm going to simplify before I multiply. So if I divide by 5, that would be a 2. This would be a 5. I divide by 2, this would be a 1. This would be a 5. So this would equal 10 over 5, which is simplified will be 2. And then we have 2 to the power of still negative 3. And so 2 times 2 times 2 is going to equal 16 negative. I'm sorry, not 16, Lord help me. Negative 8. What I meant to do. 8, negative 8. Negative 8. There we go. Negative 8.
The weight of an adult alligator is shown at the right. A juvenile alligator weighs about 2 to the power of negative 6 times the weight of the adult. How can you determine the weight of the juvenile alligator?
Apply the product of powers law. So you have 2 to the power of negative 6 times 2 to the power of 9. And then you add the exponents. And that's going to be 3. And 2 to the power of 3. And then you have 8. So the juvenile alligator weighs about 8 pounds. So let's evaluate these expressions. So we have 4 and 2/10 times negative 11 times 4 and 2/10 times 13. So first, first we're going to add the exponents. 13 and negative 11 would actually end up being 2. So you have 4 and 2/10 to the power of 2. And then that would equal 17 and 64 hundredths, 4A. Then we have B, and for B we have negative 2 and negative 1. We're going to add that together. Negative 2 and negative 1 will actually equal negative 3. So now we have 1/3 to the power of negative 3. And then we're going to have, because it's negative exponent, it's going to be the reciprocal. So that would be 3 to the power of negative 3, which in turn is equal to 27. Now we have C, and C is 6 and negative 8. We're going to add that together. That would give us negative 2. So we have 8/7 to the power of negative 2. So the reciprocal would be 7/8 to the power of negative 2. So 7/8 times 7/8 is 49 over 64. And that's it.
Evaluate the quantity 2 and 38 hundredths to the negative 5th power, to the 0 power, plus the quantity 604 divided by 729 to the negative first power to the negative first power, plus 9 to the negative third power divided by 5 to the negative third power.
So we have this evaluated by using the zero exponent law. And so as you can see, the ones that have 0 equal 1, so that equals 1. And so we have 1 plus the remaining expression. So keep doing it. And then we have continue to evaluate using the identity exponent. That's that 1 there, so it stays the same. Then we have the power of quotient law. And so you have that negative with the 9/5, and then you do the reciprocal, and then now we evaluate the rest, and it equals 2. All right, so we evaluate this. Okay, so we have any exponent to the power of 1 that's the identity law, so that's 13 over 17 plus 1, because if it has an exponent of 0, it is 1. So then that would equal, okay, so this would equal 17 plus 30 over 17. And that's that one. Then we have B. This would be still the identity law, so that would be, okay, so this would be 9/8 to the power of 2 minus 4/3 to the power of 2. Okay, now evaluate that. So this will be, so I have 16 over 9 minus 81 over 64. And then, oh my goodness. So then now they have to have the same denominator to add or subtract. So oh my goodness. Okay, let's simplify first because that's going to take too long. All right, let's simplify. So, wait, no. Okay, I got it. So, I forgot about the -1 here. So, now this has to be rewritten as 16 over 9 minus 64 over 81. And now I need to have the same denominator, so I'm going to make 16 over 9 have 81 by multiplying by 9. So now 9 times 16 is 144. I'm going to write it up top here. 144 over 81 minus 64 over 81. So now 144 minus 64 is 80. So my final answer is 80 over 81. 80